This here is one of the worst bodge-ups of a distribution board that I have ever come across. And the worst thing is, it's actually quite new. Can we just do some testing? No. I'm only getting 155 volts. I think this generator is faulty. I can't believe I'm doing this. So absolutely typical. It just fell out. Brilliant. Let's go get another generator. We're just going to do one big rip out. That is satisfying. I really wish I could emphasize how much of a nightmare it's been doing this. Yeah, but it's going to be like trying to unplug itself. Ouch, that really hurt. This distribution board here is powered via that distribution board that we've got to rip out. And this distribution board cannot be switched off because this is doing all of their critical infrastructure. This is doing servers and computers for multiple buildings. So a little bit complicated. I'll show you our workaround. This is our workaround. This has been suggested to us by the IT department to keep their servers up and running. They have equipment and things that will clean up this power. Can't say I'm a fan of putting IT equipment on an old petrol generator, but we'll do as we're asked and it should keep it up and running. So let's actually check this thing works. It's just a hire generator. So we check the fuel, we check the oil, switch it on. After a few tries, she started up lovely. Happy days. This is the frame of the DB itself, but then we've also got a contactor box going on the top. So a lot to do and also a lot to explain and hopefully some bits and pieces that we can teach. Are you wired in that side already? No. Oh. Oh yeah, that's perfect. Right, let's get this wired into the generator. So we've managed to limit their load on this side of the building at least, where we're connecting this up, to under 16 amps. We should be fine just to run it off of one of these. However, if that doesn't work, we'll run another lead up and give them another 16 amps. This is a 5 kVA generator, so it should be fine. So this cable here is Tough Sheath and it's made by Doncaster Cables. It is, in my opinion, one of the most underrated and underutilized cable that Doncaster Cables make. If you've used the EV Ultra cable, this is basically that without the data core. So it's just a dream to strip. That came off, no sweat, no problem. And I've stripped that in cold weather and it's the same. They changed the polymers within the cable jacket and the bedding to basically make it easier for electricians to work with. But you would use this cable when you need something that's going to be hard wearing and tough outside, but you don't need that mechanical protection from SWA. So say you're going to put this inside of a duct, or you're going to be clipping it direct outside where you're going to get UV exposure. This is your stuff. It's easier to work with, it's more flexible. I'd say this is like the mid-ground between a HO7 cable and an SWA cable, which to our non-British viewers, they're probably going to be completely lost by that, but that one's for the Brits. You're welcome. Try it out and let me know what you think in the comments below. Being honest, this cable that I was ordered was for the inside work, and last minute we've decided to use it outside because we didn't originally know that we had to keep the lights on. Probably isn't the nicest cable for this exact use, but it really is an amazing cable worth checking out. Of course, I have a good work friend with me today, cheaper than therapy and makes us twice as productive, matching my energy, but at the minute it seems like he's trying to match my style too. I like your glasses, mate.
Thanks, man.
I feel like I've seen those before.
I don't think you have.
No, I think I have.
No, I don't think
Do you feel like you've been influenced?
Don't think so. No, I found them online. Amazon. Yeah, baby. Yours are different. You've got the leopard print ones anyway.
This is ready to go. You ready to do your end?
I'm ready.
No.
No, I am. You be down here. I'll be up there. I call you. You speak to me. And then we go 3, 2, 1, shut off, disconnect, reconnect. You come here, and then they're on.
Well, before we reconnect, can we just do some testing?
No.
My test meter is in there.
Fine.
So I've got this, which is an adapter that Q-Tech make, and you can basically wire it onto whatever you want. They have a 3-phase version. You might think it's a little bit overkill, me plugging a multifunctional tester into a little generator like that, especially given that it's temporary. We're not powering up a pressure washer, we're powering up a part of a building, which people are going to be occupying and using. Very quickly, it seems it was very much worth plugging this in because we're only getting a reading of 155 volts. And
that's why we test it.
That's why we test it.
It's a good thing I said we should test it beforehand.
Can we just do some testing?
No. Okay then.
Earth rod. It's at this point I know some of you are going to be shouting at your TV, what's wrong with it? And you're going to be saying, it's not the earth rod. That sort of generator doesn't need an earth rod to work. We have got
A piece of copper pipe.
a piece of copper pipe. Oh, let's not use a mallet. Yeah, I know that now, but at the time I was stressed. I was under pressure.
Go on, let me use my mallet.
No.
He thinks he's so big and strong.
Let's see if we get a reading off that. Oh, mate.
Okay.
We needed to get this thing up and running so we could get cracking with the changeover of power and get the distribution board changed. And whenever you have weird earth or weird neutral readings, weird voltage readings as an electrician, usually it's a problem with the earthing or the neutral point arrangement. So that felt like a logical thing to check.
Oh yeah.
I don't think it's going to make a difference, but it's worth a try, isn't it?
I think it's going to make all the difference.
Okay.
To be honest, I reckon we'll get about 180 volts now. Still unusable.
Yeah.
Okay.
Still no good.
Well, that's a bit of a pain this morning, isn't it, really?
I guess actually, thinking about it scientifically, that makes absolutely no difference to the circuitry within that.
Why don't we think scientifically to begin with?
Our morning plan has completely gone out the window, so with Chester on the phone to the generator company trying to get a new one that actually works, I thought I might as well set about trying to actually fix the one that they've provided. Sometimes you forget, oh yeah, I'm an electrician, I can fix this stuff. Just because I've hired it, just because it's not mine, doesn't mean I can't try and diagnose the problem. I'm getting 200 volts now. After a very short while, we managed to get to the bottom of the problem. It's a loose connection inside the generator, in fact a couple of loose connections. When we've touched that cable tight up against the contact, we managed to get the voltage back up. It just fell out. Brilliant. All the connections are just falling out. Now there are two options we have here. We can spend some time fixing someone else's hire generator, or here is our Caravan Club bigger boy. Let's see if it actually starts up. So you have to pump up the fuel. Great. With the cable so short and tight, we could play country music on it. Hopefully we have a bit more. Have you got it?
Hold it.
Yeah, but it's going to be like trying to unplug itself. We decided we're going to definitely need more length.
Don't let go.
One other curveball is we don't have any diesel, we've only got petrol. If this thing runs out of diesel, it's going to be a pain because diesel engines airlock. So you have to take it apart and blow the air bubbles out basically with diesel before you can actually get it to run again. But despite all of that, very soon we're plugged in and ready to do the switchover. Oh yeah, boy. That's the stuff, that's perfect. That'll be enough. Ready when you are.
Right, if you switch off, please.
Okay, switching off.
That's switched off. Right, now if you go to the other end to connect in.
Oh, that really hurt. That floor is really slippy. I finally stacked it. These dust sheets are not safe. So whilst recovering from my broken hip, Chester is here dropping out the main supply, which is now dead, locking off all circuits which are not being used and putting in the new generator temporary supply.
Lights are on, power's on, faulty RCT. We'll get that one switched over.
Right, I reckon it's time we get some lunch. Today is being a disaster. I knew it was going to be an interesting board change, but I didn't know it was going to be such a disaster with the generator and stuff. But that is actually, if I'm being honest with you, that is what I love about my job, because no 2 days are ever the same. Do you know what is not a disaster? 1, Marks and Spencer, where we're going to go and get our lunch, and 2, Tradeify. While I've been working, I've got some inquiries come through, which is awesome. See this? My office is being managed while I'm on site working. It is impossible to work a job with your phone ringing all the time. If customers want to get hold of me that I'm already working for, they can contact me or the office. If I've got a new inquiry, it doesn't come through to me, it comes through to Tradeify. Then from Tradeify, I can transfer that inquiry over to a quote when the job is done, over into an invoice, business management, to some level, job management. If you want to try it out, they've sponsored this video. The discount code is down below where you can get 30% off for 3 months and a free trial. Let's go get some food.
Thanks.
Okay, so this is what's known as an MCCB panel. They have absolutely butchered this in. Rather than relocate the circuits, they've run a temporary feed from one supply over to this linked it through these Henley blocks here and back off and out. So there's like multiple supplies in this building, multiple meters, and it's just a big, complicated mess. However, we're not going to use this because they don't need 400 amps over this side of the building. It's very low load. We're talking like some sockets, some lights, some bits and pieces. And the standing charge on this is massive. It's like £63 a day or something absurd. So we are not going to be connecting up to this main head. We're going to be connecting up to this, which is supplied from elsewhere, which we'll show you shortly. But for now, we're just going to do one big rip out. There's a lot of history behind dust sheets, you know. Napoleon Bonaparte, guy who won the Battle of Hastings, he died
Because
he slipped
on
a dust sheet.
wow.
That's the way champions go.
Oh mate, oh, I'm so sorry.
So these up here are contactors that will pull in and out when the A1 and A2 circuit is energized on them. We don't really want these to be up here. We want them to be inside of the distribution board. Don't we, Chester?
We do.
So what we're going to do, take these out. I'll keep them though, because these are handy. We're going to install contactors inside of the distribution board into a top box. Okay, so this cable here, this is called an SY cable. So it's like a steel wire armored cable, but it's like a braided flex instead of the normal traditional steel wire armoring that we're used to. But it is not a cable for use in this situation. It's not even a BS rated cable. It shouldn't be used like that. It's more for controls, control wiring, motor wiring, that sort of thing. Fortunately, our job is to rip it out. That is satisfying. Obviously nothing at the minute is labelled, nothing is clear. The labelling that is here doesn't really relate to anything, like you've got 10, 10, 10. It's not in any order. I'm gonna go grab a piece of paper, take note of every circuit that we are removing and try and put it back in roughly how we took it out. We've ripped out a lot. We have ripped out a lot, but there is still so much left to go. A lot of these reds were already cut out of the lighting circuits. Now, the trouble is, we are redoing the lighting here eventually, but we've been asked very strictly, please do not touch any of the ceiling containment or any of the ceiling lighting because the ceiling contains asbestos. So we are really having to guess. There's minimal testing that we're able to do. And we really could do with this up and running before we then replace it with new lights. I've sussed out some that are definitely good to liven up, that are good to go. The others, I'm gonna try and pull out of the trunking as far as I can before it goes up to the ceiling, just so that it's a bit tidier in here. Circuit 5 is a C10, and that is one of our lighting, so we'll make sure it goes back on that. I'll tell you what, we'll remove breakers as we go, shall we?
I really wish I could emphasize how much of a nightmare it's been doing this, because we're not just working off of someone else's wiring and sometimes, if I'm being honest, bad work. We are also trying to work off of someone else's designs. Someone else has already started this containment and bought a lot of the materials for other things. Now, yeah, you could say, well, I'll just rip it out and start again. Not every client has got that budget, so sometimes it just is what it is.
Turn off.
Yeah.
Here I go. 3, 2, 1. Off. Ready?
Oh, that was a loud bang. Heard that from out here. All right, yep, sweet, I'll prove dead. See you in a bit, mate. Let's get this board whipped off.
Now, taking things apart is always very nice, quick and easy, and this board did come off a dream. However, here's where the interesting part of this board change is going to start. We can't actually verify a lot of these circuits. We couldn't verify a lot of it until we turned the power off. Now we've got the power off, we can start to trace things out, follow them through their routes. It's where the fun is going to really start.
This trunk in here has got to go because it's too small, it's very old, and it's in the wrong place. Well, very old isn't a reason why it's got to go, but it's just not exactly in the right place for what we need. I can't take that off because that is one continuous length with loads of cables in it. So I'm going to chop it here and then try and joint that into our newer stuff. So let's get it chopped out.
So we're trying to cut and tie into the existing containment system here. So at the moment, they've got this 75 by 75 trunk in, which at the time of its install, probably 40 years ago, was done beautifully. We're extending off of that with 100mm trunk in. If I'm being honest, I wish we did go for 150 by 150. Bigger is always better when it comes to containment. You want space to play, space to expand, but again, trying to use what we have on site, trying to save money, do things efficiently, and also bearing in mind that this is quite a light load distribution board. Most of the heavy loads are going to be elsewhere within the building.
There we go. Mwah. So pop some holes in that, we'll get that mounted up, and then we'll get this new distribution board all mounted up. Good morning, welcome back. It's another day. I'm wearing shorts this time. I'm all appropriately dressed for the weather. All right, I'm thinking of making a cardboard skid. I don't want to drag this across their new floor. This is a special, in layman's terms, it's a really expensive floor that I don't want to scratch. I wonder if I can just drag that now. There we go.
With another idea working, I guess you could say, flawlessly, it's time to continue where we left off with that trunking.
While Chester is faffing with that, because it is a faff, it's becoming a bit of a one-man job. So I'm going to start another job, which is rolling out our lovely Doncaster Cables tough sheath cable to wire up some single phase and some 3-phase sockets. Let me show you where they are. So you see here in the ceiling, these boxes that are mounted on the underside of the tray. All we need to do now is get wires to them. So obviously we're running 3-core to all of the single phase ones, and then 5-core tough sheath Doncaster cables over to all the 3-phase ones.
So I have been pulled away from this job and over into another emergency job on the same site. In the meantime, of course, we've got Chester in the house who's going to be carrying on with the containment.
And this is what we're going to do. Board is going in the middle. You're going to have a little extension box at the top, / contactor / emergency light control, perhaps. We have 2 75mm drops down the side. Time is of the essence. We've got to get power back onto this place.
My preference, if I'm being honest, doing this sort of work is to use Paxolin. Paxolin board is like an insulated paper-based material. I think, in my honest opinion, it's a little bit more future-proof. However, again, in this instance, we've got to work with what we've got. This is a perfectly acceptable, very tidy, very nice way of doing it, and Chester is doing a smashing job of it.
Ta-da-da-da! Trunking is in on one side. We've got our 2 lengths cut beautifully. Now, before we go much further, we need to cut out our entry holes. We're doing 44mm. So before we do that, we need to cut out the holes in the side of our DB. So let's take this bad boy outside. This is so delightful to have, but this is going to make my job so much easier. We'll cover up this buzz bar chamber, just like that there. We've got our lubed up hole saw. Let's get down to business. All of our bird edge collected around the magnet here. Even our cutout hole caught from dropping into the buzz bar chamber. Still very hot, still very hot. Okay, minimal burrs caught by my lovely old, very old, don't judge my style by this. Shoo, 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 shoo. Get the majority of that off. Shapow! I have a clean magnet-ish. There was actually a hole, which is really annoying, defeated the object, but that's the principle.
It can be really frustrating on a job like this when one of you is starting a job and the other person is carrying it on. Not just in terms of us taking this job over from another contractor, but even here with Chester having to drill these out using my previous measurements. The nature of this project is there's various rooms, various sections of it, some of which unfortunately we can't film, and we're just having to put out fires, run around, fix things, get things going, keeping the wheels moving.
Chunking is up, holes are in. Now it's bush time. Long bushes with our spacer lock rings, always important. I've done it before where you forget the lock ring, and boy do you pay for it, so do not forget. Woo. And I level, does that look level? The level looks level to me. We just added a little extra unistrut here, just to give a little more support to our 75mm trunking, so it's going to sit on there beautifully, and the trunking is outside. Trunking is outside. Beautiful. We're having to extend some of these cables. Look, SWA's in the top. Into our header trunking. And now, because they were a little shorter before, we have to extend into our new board. We're going to put our breakers in the top. That's absolutely fine. So it's the shortest run possible. But we're just going to have to through crimp and extend with a little bit of lovely, delicious heat shrink.
You probably don't want to heat shrink it until you've crimped it, ideally.
Okay, oiks, we are getting there. Our 2 subboards, 2 of the 4 subboards, are in up top. So the last thing to do is take off this backer plate and then reconnect it in to the bottom of our board, main switch, SPD, bam, bam, bam. Let's crack on. Just twisting the cords. There we go. We're going to reuse the gland as well. Got the prettiest shroud that's ever been put on. They've gone and put Lisa Simpson's dress on it, basically. Oh yeah! Got a little indentation on the central of this panel. Well, that's obviously where we're going to bring in our main cable. So So there's no guesses as to where we connect in, which is brilliant. Well, that's the puppy. 32 mil. Okay, let's cut. Real strength isn't defined by the size of your biceps. Now we need to allow for our banjo. So I'm going to use a cable tie as a reference. This is going to be simulating the length of the cable in the finished location so that we get it to the millimeter exactly how we want it to look. So I'm just going to tie the cable tie to the cable with the cable tie. Just like that. Let's hold our cable in about where we want it to go. And you can see from straight on that that looks like a nice swoop up and in. The cable tie is on the back of the cable here. I'm going to use this as replicating that distance on the cable, because what we're doing, we're working out where we're going to slice this to cut the cords, which is in line with this chamfered edge. I'm going to use this and measure that to the back of that chamfered edge, so it's to here on the reverse. I'm going to hold that in place, and then I'm going to shunt this down so that that is nice and smooth. It goes a little bit like that. That cable tie is touching right at the top here, and it is on the behind there. So with that, now I know that if I pull this away, so that cable tie sits here, that is the line that I want to make my cut. The last two. Look at that. Go on, darling. That's it. At this point, we realise we forgot the shroud. Okay, so now main switch time. Let's get this kitty on. With the Hager, we have these little links that allow us to bolt on. And then, after that, it allows us to stick in our Type 1 and Type 2 SPD. Let's tighten them up, that's good to go. That's the easiest fitted SPD I've used. Okay, just going to do a little test, make sure that these two subboards are safe to turn on. Neutral, L1, L2, L3, our SPD connection, and our earth all in, beautifully made off into our gland. I think this is something very special. So important to make sure that we're getting our connections to the right tautness. We can see on the side of this board here, it's got this little, can you see that back there? 3.6 nm.
Now, I don't want to talk behind Chester's back. However, what he means here by nm is Newton meters. That is the SI unit of measurement for torque. It is essential that you follow the manufacturer's instructions on installation, and very often on accessories, it will give you a torque rating on the side of the device.
We are going to run through a series of three-phase tests that we need to do to confirm that this is all okay, because this is actually a sub-main from over there. So we need to get some insulation resistance, we need to get ZDB or ZE, but here because it is a sub-main, it's ZDB, which is our external loop impedance. We need to test phase sequencing, polarity, a few little bits and bobs. This here is the Q-Tech KT66DL, and I love it. Okay, so Chester is on the other side of this circuit, linking them out. The first thing we want to do in a test, three-phase, single-phase, doesn't matter, is we do the continuity of our circuit protective conductors, also known as R1 plus R2. So I'm going to put a test meter across my live conductor. Start on an L1, yeah, Chester?
L1, baby. There you go. Have that.
0.1. Now I'm going to move across to L2, which is our black phase, 0.09. So it's approximately the same. Because the conductors are the same size, I would expect all of the readings to be the same resistance measurement. So now we're going to move over to L3, 0.10. So yeah, now that we've confirmed that everything is there, we've confirmed that it's a complete circuit and it's all in the right place. By doing that, we've also confirmed our polarity. It's not bad practice to check the continuity between the neutral and the earth, because by doing that, you're doubly confirming the polarity, and you're also confirming that there's no loose connections there. This is one line from there to there, so there's not going to be any loose connections. But we're now going to switch over to insulation resistance. I'm going to set it to 500 volts. And now I'm looking for a reading like this. Over range resistance, so over 1000 mega ohms. If there was a short circuit, it would look like this. And it would feel tingly. We'll check between all of our phases. You're separated out, yeah, Chester?
Yeah, I'm not on.
I'm just going to fly through all of these. L2, L3. Great. The other thing that's good practice, even though it's bonded, is just to do insulation resistance between the armouring of the armoured cable and each conductor. That concludes live testing. Chester has just turned it on. So now what we want to do is confirm the voltage. So between our phase and neutral, we expect 230 volts. So that's the same between all of the phases. So we want to check that we've got our voltage and that's within range. However, when we go between phase and phase, we're expecting a different voltage. Any guess what that would be? Approximately 420 volts. And we want to check that that's the same between all of them. So once we confirm that we've got the correct voltage without voltage drop, we're also just going to check between the different conductors. Yeah. The next thing we want to do is we want to check the phase rotation. So I'll quickly draw that out for you.
You've got each phase alternating current, yeah, at 50 hertz. And then if you was to have L2, this one's going to be just slightly off. And then another one is going to be in its half cycle while that's going on.
You can either get a phase rotation tester, or you can set your test meter to phase rotation, which is that one just there. Most of them have it. L1, L2, L3. So brown, green, yellow, blue. Brown to L1, green and yellow to L2, and blue to L3. And then we'll see the phases are spinning the correct way. If they're out of phase, this is how it would look. It would say on this tester, no three-phase system, or even spinning backwards. In three-phase, you can go in any order. I've gone there, there, and there. You can still do that as long as you've got L2 after L1, if that makes sense. So you could, if you wanted to, go L2, L3, L1, or any version after that, because ultimately it's a circle, as we explained earlier. So wherever you fall on that cycle of the spinning rotation of a generator doesn't really matter. So we've confirmed our phase rotation. So next thing we want to do is ZE or ZDB. So we're going to set our test meter to loop high. So we're not actually testing externally necessarily, we're testing back to the supply and then back from that. So we call this ZDB. But what we're going to do for that is a 2-lead test, and then we're checking between phase and earth. So 0.23, then L2, 0.23, L3, 0.24. So that is checking our earth path back, basically, the continuity, the impedance of that circuit back. The max allowable on this system, if we were testing back at the main head, because it is a PME system, would be 0.35. So 0.24, perfectly allowable, especially considering that this is well within the circuit, well within the system. So the next thing we want to do is our potential earth fault current and then our potential short circuit current. So our potential earth fault current, technically, is 950 amps. But then because it's three-phase, we take the highest reading and we double it. To work out the fault current between live and neutral, we need to set it slightly differently. So we're going to set our test meter between line and neutral now, and we're going to use our line probe and our neutral probe, and all we're going to do is we're going to go between phase and neutral, test that, 990 amps, and then we're going to test here, 796 amps on that one, and then test here, 900 amps. So what we do is we take the highest reading out of the three, which was the 990 amps, and we double it because it's three-phase. So the reason being, in a fault condition on three-phase, you're going to be looking at much higher temperatures, which is going to mean much higher resistances. So the regs are, take that highest reading, double it. So that means our fault current here is just under 2,000 amps or 2 kA. So that is it. We'd be ready to switch on. Not too bad, is it? Okay, so as you can see by all of this, we're not finished yet. We've still got 1 day left in the planned budget for this job. So we've got to get all of this down, through, dressed in, suss it all out, work it all out, but don't worry, tomorrow we're bringing in the big guns to jump on that DB. I can't wait to show you who it is.
And it's me. I am the big guns. Probably not the biggest of guns, but in desperate times, the only guns that were available. I did actually have some lovely help from the north, but tragically, I lost a whole day's worth of footage. Let me tell you something. This is actually, I would say, the wrong way to do a distribution board. The way you should do it is you should have your circuit schedule laid out, build out your board with all of your breakers, making sure that on each section, you're not going over 100 amps, and then you want to start wiring from the bottom up. You don't want to do what we're doing. We're having to build a plane while it's flying. It's not fun. We're having to add circuits, make things live, take things offline, put things online. That's my advice to you. Don't do what we're doing. Take your time, design it first, build your board, do it methodically, and you'll get a nicer finish.
All right then, DB, see that? Finished. Could it have been done better with the circumstances? I don't know. But overall, in an ideal world with a perfect circumstance, I would say possibly. For now, we are tested, we are certified. The customer can scan their little QR code and they're going to get their certificate. They can get all their information there. It's been a pleasure. Good night for now. Thank you for watching, you filthy animals.